So yesterday, at the end of the day, I had a little teaser tweet about something exciting that I had found in Lucee. And it's the fact that the Lucee CFML syntax supports immediately invoked function expressions, or IIFEs, pronounced IIFEs. An IIFE is simply a function expression that is invoked as part of its declaration. So if you can imagine, a function expression might look like x equals something like this, right? An IIFE then becomes the immediate invocation of said declaration. And we do that typically by wrapping our expression in parentheses and then immediately invoking that expression. So here we can take this fat arrow function syntax, wrap it inside the parentheses, and then invoke it. And then the invocation of this can have a return value, and that return value then becomes the result of this invocation. So in this case, afterwards, the myValue variable would hold the return value because we're passing in the function expression to this set of parentheses, and then we are immediately invoking. Now, you may never need to use this in Lucee. This is a common practice in the JavaScript world because it allows us to do things like create my private variable, which then can be acted upon by some sort of closure that's passed out of scope. You might choose in Lucee to implement something like this as a ColdFusion component, completely reasonable. More than anything, I'm just excited by the fact that the Lucee CFML syntax supports this, because it's a demonstration of how Lucee sort of just gets out of your way and allows you to move on with the problem, with the business of solving problems. So to look at how this could be used, let's take a look at a simple example. In this case, what I'm going to do is create a nextID function that we can just call over and over again in order to create an increasing ID value. And that works, again, by defining this function expression and then immediately invoking that function expression, right, the IIFE, immediately invoked function expression. We're going to pass in a default value for our counter, which then becomes the argument here for this function expression. And then we're going to return a function from our function. So essentially this function becomes a higher order function that returns another function as its result. Now the function that it's returning is this increment and get function, which is acting upon the ID that was passed into the higher order function. And this becomes a closure which closes over this ID, allowing it to continue to act on that ID even when this gets returned out of scope. So let's take a look at how this works in the browser. And you can see here, after calling the nextID 3 times, we're getting an incrementing value on that ID. Now, of course, you could have done this by just declaring the ID in the parent context and then calling, ID on it whenever you need to. But the benefit here is that we don't have to pollute the parent scope with variables that don't pertain to anything but the logic around their incrementation. And of course, I'm just showcasing the support in Lucee. I'm not trying to sell you on the idea of actually using this pattern. That said, let's take a look at a little bit more of a robust example. In this example, we're going to take this HTML parsed document, this XML document, and we're going to create a depth-first iterator over the elements. And we're going to do that, again, using an immediately invoked function expression, or IIFE. And here is our IIFE. Can I fit it all on one page? Almost. What we can see here is that the IIFE takes the XML document, our parsed HTML document, as its argument. Right, here's our XML document. It's then going to return a public API, and the methods on this public API, has, next, and next, you see are going to operate on the private variables within this IIFE private scope. They're closed over these variables, and again, therefore they can act upon them even when these functions are passed out of scope. And then what we're going to do is just say, while iterator has next, we're going to output the name of the elements. And if we run this, Here you can see we get a depth first traversal of that XML document, HTML head, title, body, H1P, the strong within the P, and then the block quote, which was a sibling of the P, right? Here's the H1P, the strong within the P, and then the block quote, which is a sibling of the P. So you can see we're doing this depth first traversal of that XML document. Now we're doing this by using XPath to just query for all of the element nodes in the given document. XPath does by default a depth first search, so we get to use that to our advantage. All that's going to do is return an array of nodes, which we're then going to get the count of and keep track of where we are within the index. HasNext then simply needs to check to make sure that our current traversal index hasn't gone past the bounds of the returned array, and then next simply acts upon that private node index and returns the XML element in that XPath resultant array. And you can see here that I'm actually calling another method on this returned API. You can see if not API has next. So if the iterator is at the end, we throw an error here proactively telling you why you're about to have an error. And again, you could wrap this inside of a ColdFusion component. That might be more idiomatic inside the ColdFusion world. But this is just, again, a demonstration that this IIFE, this immediately invoked function expression construct, works quite nicely in Lucee CFML. And I don't know, that's just exciting. Again, it's just a showcase of the fact that Lucee really just gets out of your way, doesn't have a lot of barriers within the language implementation, and allows you to focus on solving business problems. And that's just, I don't know, it's very exciting.